Nuclear power is somewhat harder than aluminum, although I've minimized the impact of any fluid loops. There's still the basic problem that unless you are very careful and use exactly the right recipes, you have to deal with nuclear waste. So I started thinking about my power situation. I was running low. I had 43 gigawatts, and I was committing more than that maximum, and my actual amount I was using was creeping up within a few gigawatts of what I was producing. And I still had to make some more stuff. So I started building the nuclear power plant. And I did start small. I started with 3 towers and basically one machine of each kind. And I got a pilot plant going and made sure it worked. And the first thing I did was I made absolutely sure by just scavenging and scrounging and going over all of the machinery very carefully to make sure that if nothing else worked, at least my waste management would drain all the waste. And it was a good thing because I got the first one going and it sort of worked, but there were some problems. So I shut off the inputs. Oh, you can change the programming of the drone ports remotely. So I was able to go to a drone port well away from the reactor and change it up so it stopped delivering. And you wait, and eventually it drains out everything and all the radioactive stuff. Well, almost all the radioactive stuff goes through. Got that working and went up to 3 towers overclocked. And that made everything a little bigger and overclocked everything. And that worked, mostly. Debugged that. Then I went to full scale. And I have been working all day at finding just one problem after another where in the process of doing all of this, most of it by hand, in one place or another, there'd be a belt missing or one of the constructors wasn't overclocked properly, or a belt was supposed to go to a merge unit, but instead it went to the constructor behind it, so I didn't get any of the other units. And the quick wire was a pain for that. I kept clipping my output into the second constructor rather than into the merger. Okay. Anyway, so now I have all of this running, and it's 15 towers running at 240%, and that gives us a production of 90 gigawatts. And I just started it. I hope I can just leave it going. What I did this time was I cut power to the pumps so that I would build up a few fuel units in each power plant, and I waited until I had 3 units in the power plant, and then I turned on the pumps, and it snapped right up to 90 gigawatts and held there. It's been stable ever since. So let's take a look at this nuclear power plant that has no waste. First off, up there in the distance you see my uranium mine, and that is on a impure node. There's 1 impure node and 3 pure nodes on this map. So I grabbed the impure node and I said, I am going to absolutely drain it. So I put 3 drone ports up there, and we've got 3 drone ports down here pulling from the 3 ports up there, and we pretty much keep them drained. In fact, I'm a little worried. This should have backed up by now, so it's possible that my delivery system is underperforming. In which case, if I am underperforming, then my power will continue at this level until my backlog of, remember we started out with 3 or 4 fuel rods in each reactor. That'll go down over time. And if that goes down to 0, what will happen is our power will start to fluctuate, and it will average out to whatever we can support. But this should be it should be giving us here all of the uranium that can be pumped by that particular miner. Impure miner. It is possible that an impure miner on a... Oh, come on. Why is this not showing me? Resources. Uranium claimed. Okay. It's possible that the impure miner is only getting 300 per second out anyway. So this guy claims it's doing 100 per minute, and this guy claims it's doing 100 per minute, and this guy claims it's doing... Yeah, okay, so we're mining 300. It's getting split into the 3 drone ports up there, and we are keeping them drained, so we're getting a net of 100 per minute out of here. So this may be overkill, but who knows? We may expand this at some point, and I may have to run more than, I may double this up, in which case we'll have some other source of uranium. So uranium comes in. This is a 1 to 5 splitter, so this one in the middle splits 1 to 3. We ignore 1, so it's half and half left and right. Left side splits 3 ways, right side splits 3 ways, and the 6th one I wrap back onto the input. So we will get absolutely even across these 5, and the 6th one, 1 out of 6 is going to come loop back. That's fine. So we're balancing out our ingredients for our encased uranium cells, and those go over here where we balance it out to make the fuel rods. These are all at 250%. I think my numbers said 240 was exact. I bumped that up a little bit. If I get in a situation where I am producing more fuel than we are burning, then we're going to start getting a lot of radioactivity as fuel sits on the belts beneath the reactors. Yeah. But if I have too few, it will throttle by reducing our power. Anyway, not sure which one I prefer. I will probably, if that happens, I will probably favor reducing power by reducing our build rate here. I don't want to build up a lot of radioactive stuff sitting here. I always want to be consuming at each stage a little bit faster than the previous stage is supplying. So, of course, we can always bump the reactors. The reactors are sitting at 240%. You can bump those up to 250%. They'll burn slightly faster. And when one of them runs out of fuel, the other ones will still be running, and that will keep our average power at exactly the amount of power that you can provide from the incoming uranium. So now the output. This is the more interesting part. Our inputs are evenly distributed across the reactors. There's a 1 to 5 split, it looks like that, and then each one of those 5 gets split 3 ways, and that gives us 15. The outputs are all just kind of merged together because we're going to keep everybody drained. And what do we do with this? Well, we take this and we're going to turn it into uranium fuel rods. The way to do that is you take 3/4 of it into the mixer, mix it with silica and acids, you get non-fissile uranium, and that plus the other 1/4 of it goes into the particle accelerators, where we're turning into plutonium pellets. And the divide here is approximate, and I think I'm getting more waste in the machines than I should. That's probably because these guys buffer up a whole lot before sending it out. So the thing to watch there is, are we going to start backing up here? If we start backing up on either one of these belts, we may need to adjust the split. Currently, it's just sitting here with a 1/4 going that way and 3/4 going the other way. And it's not something you have a lot of fine control over. Or we might just have to live with a lot of backed up radioactive stuff on the belts. So this guy turns out plutonium pellets, which we then send to assemblers to turn into plutonium cells, which we then send to a manufacturer to turn into fuel rods, which then get, turned into, here, gets turned into points. So we are sinking it. And I'm not exactly sure how many points each one of those are worth, but it's a whole lot. So that's the real reactor. The rest of this are ingredients that I needed that I wasn't supplying elsewhere in quantity. I was originally going to import the wire. It turns out that every way I have of making wire, it's really better to transport the ingredients here and make it. So, the Caterium, sorry, the quick wire. So the quick wire we're making on site. I started building these things up. I didn't have a separate factory making crystal oscillators this time, so we're going to head and do that on site. I have absolutely no other use for beacons. The beacon recipe is deprecated. It will be removed because it's only used in an alternate recipe. I am going to use it because I happen to prefer the uranium fuel unit as a recipe. There's another uranium fuel rod recipe, but this one worked better for me when I started working through it. I hope if they're going to remove the beacon recipe, they change the alternate recipe to use something of equivalent difficulty to build. And ahead of that, basically, I don't have a major factory turning out a lot of, the low-level stuff. So I needed some cables and some wires and some rods and some plates. So I'm making those from a fairly large quantity of imported ingots. And we are importing the reinforced iron plates because I do have a good factory for that. So if we were to minimize this factory, I would take everything from this line. Stuff to the right I would keep, and the stuff to the left I'd be doing somewhere else. Nothing to the left is radioactive. So we do a crystal oscillator factory and I don't know, maybe I don't do a beacon factory. But that does mean that we would have several more drone ports. And currently, here's our drone ports. So I've stacked them vertically where I have two drone ports supplying the same thing. So for instance, we want sulfur, so I've got two ports fetching sulfur, and I'm thinking I only need one given what these guys are doing. There's three, I believe, this is iron ingots. I didn't realize when I decided what the recipes were that I was going to be using so many iron ingots. Anyway, most of this is one. Down here at the end, we've got silica. I could have made silica on site and just boosted the amount of raw quartz that I import. Actually, I'm importing quartz crystal. So I could have imported raw quartz and turned it into quartz crystal and silica. And it'd probably be about the same quantity. Give or take. But then one of them is a ratio 3 to 5, and the other one's a ratio 5 to 3. Whoops, sorry. And of course down here I've got the batteries and, nitrogen. I take all my nitrogen in canisters. And to make it simple to loop, each drone port, each place I need to use it has a drone port dedicated to nitrogen for unbottling it. And there's another one way over there dedicated to bottling it. And the two of them are bound to each other. I don't have anybody else talking to either one of them. So I can put a certain number of the empty fluid tanks in. And there'll be, at any one time across both stations, if you add up all of the empty tanks and all of the package tanks, they'll add up to the same number. In this case, I think I've got 20 in each one. Now, 6, 12, 18. So in theory, one of my drones could be blocked from landing if the incoming was full. That's okay. In fact, I want that because that'll stop me when we've caught up. But that means that we're full on one side or the other, and as you empty or fill them, it will drain from the incoming and the drone will be able to dock and pick up stuff. So if I'm filling faster, it'll choose which one based on whether I'm filling or draining faster. And that's a nuclear power plant. And now it's been running for a few minutes. Let's take a look at our power situation. I'm using a priority power switch to isolate the reactors from the main system, so I can see here that my nuclear reactors are sitting at 90 gigawatts and have been stable for however long this is. This production, this is mostly the oil platform. In fact, I think at this point it's oil platform plus the old coal factory. And coal, I've started dipping into the coal, so the coal sections of it are going on and off. So let's turn this on. And at this point, because I am producing 90 megawatts and my maximum consumption is 57, I could decommission the old coal plant and the old oil plant, but I'm going to keep them because if something happens and I have to shut off the nuclear plant, those can keep me going briefly. I may have to shut off parts of the factory for that. So is there any, speaking of shutting off parts of the factory, this is the update 8 priority power switch layout. I can put, once I give them my power switches a name, I can drop them in one of these priority groups. And these things show on and off. Let's turn these on. Basically, if we get to a situation where we are about ready to run out of power, instead of taking down the entire system, it will turn off all of the things in priority group 8, and then 7, and 6, and it'll work its way up. At this point, my nuclear plant is over here. It will never automatically turn off the nuclear plant. That kind of makes sense. If we turned off the nuclear plant, first thing is we would build up a whole lot of nuclear waste, and shortly after that we would stop producing power. But I can turn these off by hand. So for instance, I turned off reactor water briefly during startup so they could build up some fuel in the reactors without them burning it. So they started off with some. We could turn off the uranium miner up on the hill if we want to. I did that at one point and it drained out, and I was going to go up and do some maintenance, but I forgot, and now it's all full of uranium again, so anyway. Cool stuff in update 8 there. So we now have 90 gigawatts more power. Tripled our power production in one stroke. Well, one very long stroke. Basically took me all day for a couple of days, debugging and finding places where belts weren't set and where overclocks weren't set and where things are connected wrong. It looks at this point like we're not... I may have to let it run for a long time. It takes... So these are up to 4 fuel rods. We may be... I wish I was confident that this was all of the precision. 1 uranium fuel rod per 125 seconds. I'm going to take some notes on this and see if we are correct. So, 1 uranium fuel rod per 125 seconds per reactor times. So with 15 reactors, 15 per 125 seconds. So we're looking for 15 fuel rods per 125 seconds. These guys are not running at 100%. Interesting. Well, in theory, these are running 3 fuel rods per 120 seconds per blender with, I think I've got 5 blenders. 1, 2, 3, 4, 5. Yep. 5 blenders. That's 15 rods per 120 seconds. So this produces slightly faster than we're consuming. So we're doing every 120 seconds, we're turning them out, and the other side is consuming every 125 seconds. So we should be building them up slowly. Very slowly. So if I unleash these back to 240, it's going to take a bit to update that time. I predict it's going to be, let's see, should be 130 seconds. So 250 is a bit fast and 240 is going to be a bit slow. It came up with 125. Okay. What did I do wrong? 125 times 240 over 250. $120. Not precisely sure how they're calculating that 125 number. Oh, I changed it mid-burn, so it probably said that burn took, yeah, that construction took 125 seconds. Anyway, doing it a bit fast is not a problem. But what input do we need to make them at that rate? We need 100 encased cells per 120 seconds. Let's look at a different one to make sure it's not messed up. Yeah. So that's 500 cells per 120 seconds equals 50 over 12 equals 25 over 6. So 25 cells per 6 seconds is what I'm consuming here. And these guys are running 4 cells per 4.8 seconds. Oh joy. That's 250% of 8 seconds. Check that. Divide 8.0 divided by 2.5 is 3.2. What? It did say 8 seconds for... $12 seconds. Okay, so it's 12 seconds unoverclocked, fully overclocked, it is precisely 4.80000. Okay, so that gives me 4 cells per 4.8 seconds is 40 cells per 48 seconds. I'm comparing that to 25 per 6 seconds. Common factor is 2. Multiply it out to 288. It's 240 per 288 and 25. 48 is. I should be doing it based on the per minute number. Let's do it based on the per minute number. So 50 per minute times 5 machines is 250. Yeah, I should know better than to do the math wonky. I just start with 50 per minute here. This guy is 1.5 per minute. No, this guy is 50 per minute. Oh, that's easy enough. Okay, so, yeah. Uranium fuel units and your infused uranium cells exactly match the number of encased uranium cells. So, if these guys are running at 100%, these guys should run 100%, and there should be no backup. This guy's only running 64%. What's he low on? Quick wire. Okay, I debugged a bunch of quick wire stuff earlier. I wonder if it's still bugged. Oh, look at this. I have 100 deuterium ingots input. I have my output at 497. This guy is stalled. I had a missing belt. See if any of the rest of these are slowed up. See how this quick wire is coming up rapidly. Okay, so the rest of these are saturated on their inputs. That's good. So within a couple of minutes, our rates should recover. I'm not sure how it computes the 69% here. It clearly doesn't start over again from 0. It's a long-term average of some kind. I wonder, while we're watching that, I am going to see if there's anything in the wiki. Okay, this says, shows a value between 0 and 100% based on how often the building is operating. Doesn't say how long. Okay, they're not giving us the numbers here. Quick Google search. Okay, when you type in satisfactory productivity, you do get some stuff for the game, but you also get a whole bunch of, a Harvard Business Review and OECD and MIT economics and so on. So, yeah. So I guess we just wait for that number to stop moving up. So if we did that right, we should be running everything at 100% and getting, I think it's 5 extra fuel every 125 seconds. Is that right? No. 120 seconds versus 125 seconds. So we're getting it 5 seconds early and then 10 seconds early and so on. So longer term, So this is 1.5 per minute. We are producing 7.5 per minute, consuming, running these at 24, so it says every 125 seconds. We are going to consume 15 per 125 seconds. So our production rate, 7.5 per minute, is 15 per 120 seconds. So that production rate is 7.5 per minute, so my formula is right. And 15 per 125 seconds is 7.2. So we're getting an extra 0.3 per minute. And that's balanced across all of them. So an extra 1 every 3 minutes, or every 45 minutes I get an extra 1 in each of these guys. Not too bad of a thing, although if I could adjust this, well, I could put these guys up to 250%. It would mean that our graph isn't going to be all nice and linear, but yeah, let's do that. So this raises us to 25 per minute. 25 waste per minute. And fuel, we're going to be burning 1 every 120. So that's matching our production rate. So if there is excess or shortfall, it will be very small. There'll probably be a shortfall because our production isn't exactly at the rated speed. Never is. You never know when you've got a pipe running exactly its capacity and things don't work out right, or somebody stalls for a moment. So this should have bumped our energy very slightly, at the cost of occasionally having it dip. Let's unlink these so I can watch carefully. So we went from 90 megawatts, 90 gigawatts to 93.25 gigawatts. And as I said, I expect that once we have, well, if we are burning fuel faster than we are making it, then this number will go down. But it does mean that we will not be building up unburned fuel rods on our belts. So, next question is, are we disposing of our fuel fast enough? So, waste. This is 25 waste per minute per reactor equals 25 by 15 is 375 per minute. Let us make sure that we are actually processing it that fast. So, one quarter of that is 93.75. 3/4 of that is 281.25. Do 3 blenders and divide that by 3.0 is 93.75 per minute to each blender. Well, that makes sense. And that is exactly what we can handle. So we are running our blenders flat out, and they are able to keep up with that rate and no more. The blenders turn out 125 NFU per minute per blender, or 375 NFU per minute total. Let's take a look at the accelerators. I'm going to just assume that I have overbuilt my nitric acid and my sulfuric acid because they aren't showing up as having a problem. So, plutonium pellets. There's 2 of these. So these are 200 FU per minute max per XL. I've got 375. I need, this is going to be capable of handling 400 and capable of handling 50 uranium waste, and I'm giving it half of 30, 93, so 100 for both of them, 93.75, so we are well within budget on these if we can handle 120 pellets per minute on our output. So the 120 pellets per minute is divided by 6, which gives us 20 pellets per minute, and these guys can handle up to 25, so they will keep the backlog down. This can turn out as much as 12.5 by 6. This total is 75. So 75 case plutonium cells per minute. That would be 25 to each of these, and we can handle 18.75. So we did not overbuild the plutonium fuel rods by enough. So the question is, are we within margin? Each one of these is overbuilt. I would have to do the math to figure out the actual numbers coming through. That tells me that if I'm going to watch for a backup, it's going to be on this belt. It's going to be a backup of encased plutonium cells. We may be getting some extras here. And currently this is set up to divide its input evenly in 3 pieces. I didn't want to set up a manifold because that would mean I had a whole bunch of radioactive stuff hanging out on the belts in order to get more into the downstreams. I'd really rather not do another divide by 2. So what I'd have to do is take each belt, divide it in half, and divide each one of those in half, and then route them into these guys. I'll just have to keep my eye on it. Oh, right, we're overstuffed if we get above 60 here by too far. Yeah, so when it's done constructing, it deducts the inputs. And I need to have at least twice this number. So I need 60 of these in here. And that was right on. Okay, I am happy that this is all based on my original numbers, and I boosted all of these guys up a little bit, but I didn't boost these by much. I think I took these from 240 to 250. So they couldn't handle these guys at their maximum, but they could handle our steady state. So good. this is still going, and it still has 3 rods. And we still have a nice stable 93 to 50 megawatts. I'm going to accept that as my power plant, and let's connect to the base again. See how close we are to running out of electricity? Blue is our maximum consumption if all machines are turned on, and we touched there. So actual energy used approached our energy produced. Now, to be fair, this whole plant does take a lot of electricity to run. And if I really wanted to be fair, what I'd do is I'd run this plant. I basically have this switch upstream of the plant so that I could say, well, the plant is 93 gigawatts minus what this costs to run. Can we do that? Yes, we can do that. I actually have one link to the factory, which is right here. So we're going to put in a new power switch, which is whole nuclear plant. So if I turn this off, see that our external net, all of this load, see, these would have been near. But what's happened is the nuclear plant itself could draw as much as 10 gigawatts, and it's currently drawing that's interesting. Consumption is higher than max consumption. How the heck does that work? We're currently drawing 11.5 gigawatts out of the maximum of 9.8 gigawatts possible. But that's fair. So we take the power output from our reactors and we subtract out the cost to run them. And there it is. So this is actually a better place to turn it off to measure what's going on. And with this power plant disconnected, we can see that we are consuming 28 gigawatts, producing 43. Our consumption could peak at 49 if we had everything turned on out there. Okay. I'm happy with this plant. So we need to figure out the next thing I need to build. I haven't yet started on automating the 4 things for phase 4. I need to look at the next thing I need to build that gets me closer to that. I think I have some more things that I need to automate before I can start looking at those recipes. I mean, start thinking about building those. I have to look at them to figure out what to build. Now let's call that a recording. Oops. There we go. Can I go to photo mode? There we go. Beauty shot. Get rid of the coffee cup. Can I get smoke out of all of them? I guess not. Okay, so there's my cover shot for the whole thing. I think it's... I don't know what I just did there. I think I toggled full screen. Well, that's actually what I was looking for. So right now it's got it in a normal aspect ratio that I was trying to figure out how to get back to this, and I couldn't, which is why I've been recording at full scale. But anyway, there it is. So let's go ahead and call it a recording. Oh, that really did go very small, didn't it? Yeah, I now see in OBS what it did to me. I think that went to 1080p. Anyway, done recording.